So welcome to SAKALAVIDYA educational channel. So welcome to the JEE mains and advanced classes. So today we are going to discuss about the logarithm chapter. So this was actually intended to the 2024 target 2024 series. It will be continued for all the chapters. So welcome Vikram. So welcome all. Right. Let us move to right. So 1 minute. Right. Okay. So first let us move to one by one concept of the logarithms. Let's have a discussion on that one. Right. So first, this is the concept of the logarithms. Okay, Padma Ravalov, welcome. See, let a comma b two positive real numbers and a does not equal to 1. The real number x such that a power x is equal to b is called logarithm of b to the base a. It is denoted by log b to the base a. Okay, right. So for example here see a power x is equal to b. So this is called exponential form. This is called exponential form. Exponential form. So this we need to change into logarithmic form. So logarithmic form means here x is called, this x is called logarithm of b to the base a. So x is equal to, we can write log b to the base a. So both are interchangeable. That means a power x is equal to b. So then that implies this is x is equal to log b to the base a. So this is called logarithmic form. This is called logarithmic form. Logarithmic form. I hope it's very clear to you. So for example, if you write like this, 2 cube is equal to 8. So this we can write like this, log 8 to the base 2 is equal to this power 3. For example, 5 to the power of 4 is equal to 625. So this 4 is called logarithm of 625 to the base 5. So we can write log 625 to the base 5 is equals to 4. So let's have a one more example. For example, here see 1 by 1000, 100. For example, 100 is equal to 1 by 100 is 0. So this will be 0.01. So this we can write 1 by 10 square. So 10 square is equal to 0.01. So this is 10 power minus 2 equal to 0.01. This minus 2 is called logarithm of 0.01 to the base 10. So that means log of 0.01 to the base 10 is equal to minus 2. So this is the concept of the logarithm. Okay, let us move to next concept. Let us move to next concept. Right. Let us move to next concept. Right. Okay. See here, if a is a positive real number and a does not equal to 1, then logarithm of a to the base a is 1. So that means very important here, logarithm of a to the base a is equal to 1 provided a does not equal to 1 and a belongs to positive real number. A belongs to positive real number. If a does not equal to 1 and a belongs to positive real number, log a to the base a is equal to 1. So let us discuss some examples. See some examples. We have log 2 to the base 2 is 1. For example, log 5 to the base 5 is 1. Similarly, log of 2022 logarithm of 2022 to the base 2022 is also 1. So logarithm of 1 by 2 to the base 1 by 2 is also 1. See, logarithm of some 0.75 to the base 0.75 is 1. It's clear? Okay. Right. Let us move to next at another concept. So at another concept. Right. Let us move to at another concept. This is very important concept to be discussed. So my dear students, remember this concept now. Okay, let's have a discussion about this. Right. Here see, if a comma m are positive real numbers and a does not equal to 1, then a to the power of log m to the base a is equal to m. So my dear students, you see here what is given, a to the power of log m to the base a is equal to m. Here where here a does not equal to 1 and both a comma m should belongs to the positive real numbers. So this is called actually logarithmic identity. This is called logarithmic identity. Logarithmic identity. This is called logarithmic identity. Suppose, see example, let's have a discussion on examples. First example, 3 to the power of log 5 to the base 3. So you can write 5. For example, 7 to the power of log x to the base 7, that is equal to x. Similarly, e to the power of log x. Here base is by default e, so you will be getting x. So e to the power of log f of x. It will be very useful for differential equations also. So this will be f of x. I hope it's very clear to you. And also a to the power of log f of x to the base a is f of x. Is f of x. You can take the screenshot, or I hope it's very clear to you. So okay, Akshay, it is very useful for 2023 also. Right. So next concept. Let's have a discussion on next concept. See this one. Right. Okay. So first let me read this concept, then go for the explanation. If a comma m comma n are positive real numbers and a does not equal to 1, then logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. So that means this is called actually product rule. This is called product rule. So that means, for example, logarithm of mn to the base a is equal to, we can write logarithm of m to the base a plus logarithm of n to the base a. Its converse also true. Converse also true means, for example, log x to the base a plus log y to the base a. This we can write log as a single logarithm. We can express x into y, xy, log xy to the base a. We can write it. So one example has been discussed. So let me actually discuss that same example also. See, for example, here example, logarithm of 1 to the base m plus logarithm of 2, sorry, this is actually n factorial. Logarithm of 2, this is n factorial, plus logarithm of 3, this is n factorial, and plus so on dash dash logarithm of n to the base n factorial. So that means you have a one doubt. So can it be the product rule can be extended for more than product of two numbers or more? Yes, it can be extended. This is the extension of this product rule. Extension of product rule. This can be expressed as a single logarithm, log of 1 into 2 into 3 into so on dash dash into n, so n factorial. See, we know that product of the first n natural numbers, that is 1 into 2 into 3 into so on dash dash into n, is denoted by the factorial n or n factorial. Factorial n or n factorial. So now we can write logarithm of n factorial to the base n factorial, which is equal to 1. So this is the answer. Okay, I hope it's very clear to you. So let us move to yet another concept. That is, right, quotient rule. That is, we are going to discuss quotient rule. Right. So now see, if a comma m comma n are positive real numbers, both should be positive real numbers, and moreover it will be useful for NDA also. Absolutely correct. So here a does not equal to 1, and logarithm of, here see, logarithm of m by n to the base a is equal to, we can write logarithm of m to the base a minus logarithm of n to the base a. This is called quotient rule. Quotient rule. Quotient rule. Or division rule also we can say that. Yes, definitely will crack NDA. Right, for example, you see, even its converse also true. For example, log x to the base a minus log y to the base a. This can be written as log of x divided by y, or x upon y to the base a, we can write it. Right. So let us discuss this example now. For example, what is given here? If you are asked to find out logarithm of 2 by 5 to the base 3 plus this is okay, plus logarithm of 5 by 3 to the base 3. This first we can apply the product rule. So logarithm of 2 by 5 multiplied with 5 by 3 to the base 3. So 5 1 ja 5 cancel. This is log of 2 by 3 to the base 3. So it appears to be rather log m by n to the base a, which is equals to log m to the base a minus log n to the base a. So that this can be expressed as log 2 to the base 3. So minus, we can write log 3 to the base 3. So my dear students, log 3 base 3 is 1. So log 3 base 3 is 1. So that we can write this is log 2 base 3 minus 1, we can write it. Okay. Raghavendra, okay, it will be continued in this session. Definitely it will be continued in this session. Okay. There will be the clear discussion of all the concepts, basic concepts, as well as the level 5 problems also will be discussed in this year. Please try to understand. So next we are going to discuss one more rule, see, in logarithms. So these properties are very, very important. If a comma m are positive real numbers and a does not equal to 1, n is any real number, n may be a negative also, n may be any real number, then logarithm of m to the power of n to the base a is equal to n times log m to the base a. So my dear students, you remember logarithm of m to the power of n to the base a is equal to n times log m to the base a. So here very clear instruction should be given, where here a does not equal to 1 and here a comma m must be equal to positive real numbers, and whereas n may be, power may be any real number, n belongs to R, it may be positive or negative. So clear? I hope it's very clear to you. So let's have a discussion, one example now here, one example let's discuss. For example, if you want to find out log 49 to the base 7, this is, see my dear students, this we can write log 7 square to the base 7. Using this power rule, this can be written 2 times log 7 to the base 7. So my dear students, you know that log 7 to the base 7 is 1, so that we can have 2 times 1, so it is 2. Am I correct now? Is it correct or not? So now you need to chart with me. I will give one more question, you try to solve it. So log of 1 by 100, 1 by 1000 to the base 10. So what is the value of this one? What is the value of this one? Anybody? So what is the value of this one? Just you can check it. You can check it. Akshay, Jayesh, Raghavendra and others. Vikram. So what's our answer? See, this 1 by 1000 means 1 by 10 cube, which is equal to 10 to the power of minus 3. So now this can be rewritten as this is equal to logarithm of 10 to the power of minus 3 to the base 10. So using power rule. So this can be written as minus 3 times log 10 to the base 10. So log 10 to the base 10 is 1. Yes, absolutely correct. Niharika, wonderful. You did good job. Minus 3 multiplied with 1 minus 3. I hope it's very clear to you. Right. 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 Okay, next. Let us move to next concept now. Next concept is very, very important concept. This is change of base rule. Change of base rule. Right. So let's have a discussion on this one. Change of base rule. This is very, very important for NDA and Air Force examination also, and different competitive entrance examination also. A comma B comma M are positive real numbers. A does not equal to 1 and B does not equal to 1. So then here logarithm of M to the base A is equal to logarithm of M to the base B multiplied with log B to the base A. Log B to the base A. This is called actually change of base rule. Here new base B has been introduced. Understood now? So that means, for example, see, you can see the example. For example, log 2 multiplied with base 3 multiplied with log 9 to the base here 2. What is the value? What is the value? You need to find out. Okay, Raghavendra, I can discuss problems. Okay, I got the point. Right. Now, here see, first of all, let us find out here log 9 base 2. This is equal to log 3 square to the base 2. So this can be written 2 times log 3 base 2. Am I clear now? So let us substitute here. Log 2 to the base 3 multiplied with 2 times log 3 base 2. This can be rewritten as 2 times log 2 base 3 multiplied with log 3 to the base 3. So using this property, log m to the base b, log b to the base a is log m to the base a. Here just you round off like this. So now using this property, this can be rewritten as like this. 2 times log 2 base 2. Log 2 base 2 is 1. 2 times 1, answer is 2. I hope it's very clear to you. Now I will give one question, you try to solve it now. Now I will give one question, you will try to solve it now. So for example, you consider this question now. This question. Log 2 log 8 to the base 2 into log 2 to the base 3 into log 3 to the base 2. So what is the value? We'll get it. This is very interesting now. This can be written log 3 to the base 3 is actually here. Log 8 to the base 2 means this is log 2 cube to the base 2. Into this we can write log 2 base 2. This is 3 times log 2 base 2 into 1. This is also 1. 3 into 1 into 1. Answer is 3. I hope it's very clear to you. Yes, definitely, Nikita. Right. Okay, let us move to yet another interesting concept. Okay. See. So one more interesting concept. So my dear students, you remember this log a to the base b can be written as, if you want to interchange this number and base, we need to write like this: 1 upon log b to the base a. So let's discussion one question here. So right. So now let us move to one question now. So 1 upon log ab to the base a plus 1 upon log ab to the base a, base b. What do you get now? What's your answer? What is your answer? What is your answer? What is your answer? You try this question. See, 1 upon log b to the base a, you can write. So this can be rewritten as solution, you see. Log a to the base ab plus this we can write log b to the base ab. Using product rule, this log a to the base b plus log b to the base ab, you can express as a single logarithm. We can write log ab to the base ab. Log ab to the base ab is 1. So this answer is 1. So let me give one more question to you. One more question to you. You try this question. 1 upon log of abc to the base a plus 1 upon log abc to the base b plus 1 upon log abc to the base c. So what's your answer? What is your answer? So what is your answer? So you need to say your answers also. You need to interact with me. So what is your answer? So what is your answer? Right, my dear students, you see the solution. So this can be written using this property: log a to the base abc plus log b to the base abc plus log c to the base abc. Am I correct now? Using extension of the product rule, this can be written as a single logarithm. How could you express logarithm of a into b into c? That is log of abc to the abc. Obviously, what do you get? 1. So 1 is the right answer. Am I correct now? So this is the very useful, important formula to be remembered. Very, very important formula. Result also you need to remember this one. Okay, let us move to yet another also. For example, right. Let us discuss one more property. So this can be written like this also. Let me write. See, logarithm of m to the base a can be written as log m to the base x upon log a to the base x. Here x is valid base. Valid base means x may be greater than 1 or x lies between x greater than 0 or in between 0 less than x, x less than 1. So x should be, this is called valid base. And also x does not equal to 1. You must remember, x should not be equal to 1. Here in all these cases, x greater than 1 only you need to take it. That's a better one. So x does not equal to 1. So x should be positive or it lies between 0 to 1 also. So now, so one example, let's have a discussion. One example, it may be simply we can write like this also: log m by log a also we can write it. So one question, for example, log 2 to the base 3 into log 3 to the base 4 into log 4 to the base 5 into log 5 to the base something 2. See, this can be easily cracked with the help of this concept. See, this we can write log 2 by log 3, clear, into log 3 by log 4 multiplied with log 4 by log 5. So multiplied with log 5 by log 2. So my dear students, here see, so what will cancel out here? Log 3 cancel out, log 4 cancel out, log 5 cancel out, log 2 cancel out, 1, 1, 1, 1. So obviously you get 1. Clear? Shall I give one more question to you? Right. So let us discuss one more concept now. Right, one more important property that is very, very useful property. Right. See, my dear students, logarithm of m to the power of alpha to the base a to the power of beta. So how to solve such type of questions? Based on this formula, this we can write alpha by beta log m to the base a. So for example, let us solve some examples. See, log 5 to the base 25. See, my dear students, this we can write log 5 to the power of n to the base 25, we can write 5 square. It appears to be this formula. Log m to the power of alpha to the base a to the power of beta is equal to alpha by beta log m to the base a. This we can write 1 upon 2 log 5 to the base 5. So log 5 to the base 5 is 1. So 1 by 2 multiplied with 1 is equal to 1 by 2. Okay, let us move to yet another problem. For example, log 49 to the base 343. So what is your answer? And one more I will give it. So logarithm of a to the base root a. So fourth question, logarithm of 125 to the base 625. So you try to solve these questions. Solve these questions. So what's your answer? Just expect it. What's your answer? What is your answer? Okay, my dear students, this 49 can be written as product of primes. 49 we can write 7 square, 343 is 7 cube. Using this formula, we can write 2 by 3 times log 7 to the base 7. Log 7 to the base 7 is 1, so 2 by 3 into 1, 2 by 3. This is log a to the power of 1 right down. This is a to the power of 1 by 2. 1 upon 1 by 2 is 2 times log a to the base a. Log a to the base a is 1, so answer is 2. So my dear students, 125 is we can write 5 cube. Am I correct? 625 is 5 raised to 4. So this equals to 3 upon 4 log 5 to the base 5. Log 5 to the base 5 is 1. So 3 by 4 into 1, 3 by 4. I hope it's very clear too. So this formula is very, very important, or very, very important result to solve the problems. Right? Okay, one more very, very important result to be discussed now at this time. Right. Here see, a to the power of log b to the base x is equal to b to the power of log a to the base x. Both are equal. Sometimes you may be asked like this, a to the power of log b minus b to the power of log a. Obviously you get 0, since a to the power of log b equals to b to the power of log a. Similarly, 2 to the power of log 3 is equal to 3 to the power of log 2. Clear? Similarly, 5 to the power of log 3 is equal to 3 to the power of log 5. So these are the examples we shall give it. Example 1 and example 2. I hope it's very clear to you. Right? Okay, now let us discuss logarithmic functions. Logarithmic function. This is the graph of the logarithmic function. Right. See, let y is equal to log x to the base a, or we can write f of x also. It's a function of x. This is called logarithmic function. Here 0 less than a less than 1, or a greater than 1. Base may be greater than 1, or it is a decimal 1. It lies in between 0 to 1. Always base is positive. See, the figure will be seen clearly. I will draw. So this is actually, see, I will draw figure clearly. This is x-axis. Okay. Okay. There is 1 minute. Right. Let me draw the figure clearly. This is x-axis. X-axis. Right. This is y-axis. This is y-axis. Y dash, y, x, x dash. Right. This is the graph of y is equal to a power x, exponential graph, a greater than 0. When a greater than 0, this you will get the graph like this. It cuts y-axis. And actually here, see, y-axis, if you put here, so y is equal to, for example, a power x. If you put x is equal to 0, what do you get now here? Y is equal to a to the power of 0, 1. So that means this point is 0, 1. It cuts at 0, 1. A greater than 1. So this is actually passes through the origin. Y is equal to x line. This is y is equal to x. Now this is the logarithm. That is y is equal to log x to the base a. This is a logarithmic function graph. Here where x greater than 1. Where x is positive and also a greater than 1. So this is the actually the mirror image. Both are. This y is equal to log x to the base a and y is equal to a power x are the mirror image of y is equal to x. They are symmetric about this one. And also this y-axis is called asymptote. Asymptote to this logarithmic function. Asymptote. Okay. So let's have the properties. Let's have a discussion of the properties here. Okay, 1 minute. Okay, 1 minute. So 1 minute. So now, so let us discuss properties of this graph. See, first property. See, the domain of this function is domain of this y is equal to log x to the base a function. Domain of this function means always actually domain is here to here. So 0 to infinity, 0 to infinity, domain is, that is the R plus, domain of the function. Range is all real numbers. It's a monotonic function. So it is a continuous function, this is a continuous function in the interval 0 to infinity. And also already discussed, y is equal to log x to the base a is a mirror image of y is equal to a power x. This is y is equal to a power x. So with respect to this line which passes through the origin, that is nothing but y is equal to x. So now x is equal to 0. Y-axis is the vertical asymptote to the function y is equal to log x to the base a. So this y is equal to log x to the base a cuts x-axis at 1 comma 0. At 1 comma 0. That means log x to the base a is equal to 0 means x is equal to a to the power of 0, 1. It has only one solution. And also see, this y is equal to log x to the base a or x is equal to a to the power of a. Both are inverse functions. Both are inverse functions. So are mutually inverse functions. And one more thing you remember, here when a greater than 1, when the base is, for example, y is equal to log x to the base a, when a greater than 1, that is an increasing function. So when 0 less than a less than 1, same, this is a decreasing function. Okay. So 1 minute. Right. So let us move to graph of this function. See, the graph of the function now. The graph of function y is equal to f of x is equal to log of mod x to the base a. Okay. So first, what is the domain of this one? Domain of this one means actually the mod x is always, mod x should not be equal to 0. That means x does not equal to 0. That's all. So x can have any real value. X belongs to any real value, but not 0. That means r minus 0. This is the domain of this function. So the graph of the function is this one. Then here D, domain is equal to r minus 0. This graph is symmetrical about y-axis. For a greater than 1. So this is the graph of y is equal to log mod x to the base a. Here a is greater than 1. Right. So 1 minute. Let us come to right. Okay. So for example, same, the graph of the function y is equal to f of x is equal to log of mod x to the base a when 0 less than a less than 1. Then the graph should be like this. So graph should be like this. You will be getting graph like this. Right. So it cuts at 2 points, 1 comma 0. This is minus 1 comma 0. This is symmetrical about this one, y-axis. In the previous case, the graph is like this. Graph will be like this. Okay. So in the previous case also you can see the graph will be like this. Right. So next. Right. Let us see this one. So these are very, very important. The graphs are very, very important. We need to discuss very clear manner. See, for example, here if a greater than 1, then log n to the base a is an increasing function. So that means, that implies, as n approaches to infinity, n tends to infinity, then this log n to the base a also approaches to positive infinity. That's why it's an increasing function. So this is an increasing function. When a greater than 1, this log n to the base a is an increasing function. So, and one more thing is very important, you remember. For example, a greater than 1 and 0 less than x1, x1 less than x2. That means x1 is greater than 0, positive, x2 is also greater than 0, positive. So then if you apply logarithm on both sides, the symbol does not change. That means if you apply logarithm these two values, log x1 to the base a less than log x2 to the base a. You remember this one. When a greater than 1. For example, 0 less than a less than 1, then this symbol reverses. So then you need to write like this. Log x1 to the base a greater than log x2 to the base a. This you need to remember. And one more thing. So this is very, very important. Very, very important. See, suppose if a greater than 1 and log x to the base a is less than alpha, then what is the value of x? So whenever a greater than 1, this x is less than a to the power of alpha, and also x must be positive. That means x greater than 0. So that means you say like this, x less than a to the power of alpha, equation 1 you say, x is greater than 0, second equation. Combining these two equations, then you get a equality here. What kind of equality do you get? 0 less than x, x less than a to the power of alpha. So this is very, very important result to be just remembered. I hope it's very clear to you. Right. Sai, welcome. And next, if 0 less than a less than 1, log n to the base a is a decreasing function. If n tends to infinity, log n to the base a increases tends to negative infinity. Okay, similarly you see here, already discussed. Suppose 0 less than a less than 1, and 0 less than x1, x1 less than x2. If you apply the logarithm, as it lies between base lies between 0 to 1, logarithm of x1 to the base a is greater than log x2 to the base a need to be written. Okay. Next, tomorrow we shall have a discussion, more discussion about the remaining one. Thank you. Bye bye. Have a nice day.